I would kindly introduce our first speaker. He's from Mexico. It took him a long way. It is Mr. Sanchez from Crista Curva, and he's responsible for product development, technology, and market development. Means he has a long experience in this business, as far as I understood. And he will tell us about curved glass, modern form and function, and convex and concave applications. Javier, the stage is yours.
Thank you, Stefan. Good morning, everybody. Thank you. Thank you. So who was at dinner last night? There you go. Well, so I was talking to one of our colleagues at dinner last night, and she asked me about the presentation this morning. I said it's 9:25 in the morning. She said, no, I'm not going to make it. So thank you for joining. And I also want to thank the GPD for putting this event together after 4 years. It's been a while. So I think it's a good place for all of us to come see and meet colleagues, friends, and get updated in the industry. And I want to tell you about curved glass. So curved glass is a beautiful product. We love it. That's what we make. And it allows for a lot of possibilities in design to architects. It allows for expand the imagination. And it's got a lot of possibilities. And today I will be talking about a technology that is new in the industry, that we have recently implemented, and that helps us get rid of some of the constraints that curved glass has typically had for years. And the picture that you can see here on the screen, it's about that. It's about the possibility of curving glass inside to the inside side, to the concave side, and keeping the coatings on the same surface, regardless of the glass being concave or convex. So let me give you some background. This is a project that we did in 2013. It's located in Southern California, close to San Diego. It's a hospital. And we think it's a beautiful building. It's got a lot of movement. It's got coatings, both frets and low-E coatings for performance purposes. And we'll have corners with curved glass that are curving out. We also have corners curving in, the concave side. And if you look close, you'll see that there's a color difference on those ones right there. This is another one that we did in 2018. This is in Toronto, in Canada. We have a coating on the second surface on the flat glass. The glass curves out. The coating is still on the second surface. But when it curves in, where it's concave, the coating goes to the number 3 surface. And that's how it was. That's how it needed to be. And if you get close to this building, you'll see that there's a color difference in the concave versus the convex. So that's how it's always been. Coatings, whether it's a low-E or a fret, when it's convex, when it's curving out, and I have a sample here with me. When it's curving out like this, coatings needed to be on the second surface, but when the glass curved in like this, the coating needed to be moved to the third surface. Why is that? Well, tempering machines, curved tempering machines, the way they work is that glass is running on rollers. And imagine that you have a coating, in this case a low-E coating or a fret, and when that coating is, if you put it downwards and it runs against rollers, that coating is going to get damaged, it's going to get ruined. And the glass needs to get bent at the quench, which is going to go up again on rollers. So the way to do it was always to keep the coating away from the rollers on the other side. So when you install the glass on a building, it will be like this, so the coating will be facing this way. So if you had a concave situation where you had to flip the glass around, then the coating goes to the first surface, which is not possible, or the third surface, or an uneven surface for that matter. So when we had a condition like this, where we have an undulating facade, where you needed to keep the coating on the same surface, you can see the red line over there, that wasn't possible. But now it is. The idea is to be able to keep the coating on the second surface when it's convex, or on the second surface when it's concave, like here. So the obvious first benefit of that, it's aesthetics. We will avoid these situations where you have a color difference. And second good benefit is performance. I have two examples here. I have a coating which is called SN68, which is very common in North America. It's a very clear coating. And when you have that coating on the second surface, your solar heat gain coefficient is 0.38, but when you move that coating to the third surface, it goes up to 0.46. That's a 20% loss in performance. And I've got another example here, which is it's a more reflective coating. It's very widely used in Europe. It's a stop ray Vision 50. And when you have the coating on the second surface, the solar heat gain coefficient is 0.29. But when that coating gets moved to the third surface, it goes up to 0.41. That's a 40% loss in performance. So there's a clear benefit to keeping coatings on the same surface, regardless of the curve being convex or concave. So that's the technology, and I would like to present a couple of projects that we've recently finished using this technology applied on concave curved glass. The first one is this one. It's a nice building with an undulating facade. It's in Washington, D.C. It's called 2100 Penn. It's on Pennsylvania Avenue. And for those of you who have been to Washington, D.C., this is the main road that runs into the Capitol building. It's a beautiful area. The project was designed by Pelly Clark Pelly, and they wanted to create something unique, something that stood out in the area. And they chose an undulating facade, a facade that would have movement and that would have something that they wanted to create differently. We did this job in 2020, which added to the challenge right in the middle of the pandemic, you can imagine. Anyway, so we were tasked with making these units that were concave, and the architects wanted to make sure that those concave units would be uniform, would be aesthetically pleasing in the context of the building. And so the new technology was needed because the older technology would make those units look different. This is the product that they chose. It was a stop ray Vision 50. It's a coating from AGC. It's a silverish, bluish coating, and on 6 millimeters and 10 millimeters at the inner ply. And then on the spandrel area, we had also the coating on the second surface, 6 millimeters, but we also had a frit pattern on the third surface, on the 10 millimeter clear piece of glass. The sizes of the glass were pretty normal, 1.7 by 2.6, and we have different radii. A couple of those were tighter than what we thought we could make, and that was something that we were able to accomplish. And here's a picture of what the architects didn't want. They didn't want that. They didn't want the glass to look different. So that piece of glass right there has the coating moved to the third surface like it had to be done before. And so we talked with the architects early on the design stages of the project. We were able to show them the technology, show them that it was available, and do different mock-ups and trials, and this is an example of those. They were able to see that the glass looked very nice, that the coating performed well, stayed in good shape. This was a new technology, so they were kind of afraid of this. So we did a lot of testing. Here you can also see how the low-E coating was on the second surface, but also the frit pattern was on the third surface, which at the time was unseen of. And so thanks to this exercise, the job was possible, and the results were pretty good. This is a second example of a project that we recently finished. We did this one in 2021, 2022. It's called 1101 Chestnut. It's located in Philadelphia, Pennsylvania. And it's a It's a building that is a health center. It's owned by the Jefferson Health Group, and they wanted to create an iconic building for their organization. They have a campus where they're building different towers, and this was the main one. They tasked INEAR architects with the challenge of designing a facade, and they wanted to create a facade that was undulating and that accentuated the curves as much as possible. Early on in the design stages of the project, we were approached by the consultant, in this case was Sanchez, and we were able to work with them with what was possible at the time with the technology. So, in essence, maximum sizes, minimum radii. And they were very interested in this last one, because the tighter the radius, the more accentuated the curve will be. And so we came up with what was at the time the tightest that we could make it and the biggest that was possible. So that was a very good exercise of collaboration and being able to help the architects early on in the design stages so to make the project come true in a good way. Here you can see the building. It's a pretty large building. It's 30 stories. It's 4 facades with the same design. It was about 20 truckloads worth of curved insulated IG units. That's the makeup. The coating was stop ray Vision 50, in this case on low iron, heat strengthened, and on top of 6 millimeters low iron heat strengthened. And here you can see some, the sizes of the glass, they were pretty large, 1.95 up to almost 6 meters in height, and there were 3 different radii, but the main one was 1.95, which is right at 2 meters, which is basically the limitation. So that's where they wanted to accentuate that curve as much as possible. And here you can see some images of the glass that we use for inspection purposes. The design team came down and inspected the glass at our facility in Mexico. Here are some images of the building. It's pretty much finished now. We're still waiting for some better pictures, but these are pretty good. And they can give you an idea of how it looks like. We think it's a very beautiful project, and we're very proud of it. So that's in essence what we're doing with the possibility of doing concave curves. And I've got basically 4 conclusions for my presentation. The first one is that technology continues to evolve and to develop. And what is not possible today may be possible tomorrow. And at the same time, design is always changing. Actually, design, by definition, it's everything has to be new. You want to create something different. And so it's very important to understand that when technology is evolving and design is evolving, if we as companies embrace that and we're able to adapt, it's something really, really special. And it also calls for collaboration. If we, as an industry, collaborate, we have the design teams, the construction teams, the fabricator of the glass early on the design stages and work together, the results will be great-looking buildings at cost, on time, and with the quality that is required. So I think that's one of the conclusions that I have. My second conclusion would be that curved glass will continue to be an element that supports architects with differentiating the design of their buildings. We think that's a very, very nice element in buildings. Obviously, we love curved glass, right? But we also think that this technology will help by keeping coatings on the same surface, regardless of the glass being concave or convex, will help architects create beautiful and uniform facades with these undulating designs. And lastly, we think that this technology will contribute to change the landscape of many, many cities around the world. Thank you, and I will welcome any questions.